Okay guys, this is our third video in the cabling series. And what I want to talk to you about today is patch panels. These are two different types of patch panels. We have one here that is a blank, and this is a 24 port. This one uses keystone jacks. So if you watched the last video, talked about how to use keystones or 110 punch down blocks for your horizontal cabling, riser cabling. These are keystone jacks, and what they would do is, say for example, you buy one of these, and I use these quite a bit. They take up more room as far as being able to have as many ports as you want. You see this is a 24 port, and this is also a 24 port. You see that this one has a higher density. But one of the reasons I like these is that if you change your cabling out, you don't have to change out the patch panel. You just change out the keystones. The keystones are much cheaper. So with this one, for example, I'll just put the keystone in, clip it in place, and now you have a port keystone punch down in port 12. And to get them back out, a little bit more difficult. You have to squeeze and get the clip out. But I like these a lot. Because like I say, these plates are much cheaper than a typical patch panel, and they use keystones. I can have different colored keystones for different things. So I could have blue for telephone, white for data, orange for cameras, and I can just look at the patch panel and just glancing at the keystones tell which is which. That's another reason. But the main reason is I can change them out pretty easily. So if something happens where I want to put in a higher data rate, or say we've gone from Cat 5e to Cat 6, all I have to do is change out the keystones, and I don't have to worry about it. Also, the other thing is these are for UTP. This is for unshielded twisted pair. These are not insulated. They don't have a metal foil for them, right? I haven't talked to you guys about UTP or STP yet. But shielded twisted pair has an aluminum foil and a drain wire inside it. So if I'm using, say I have some access points here in the school that the wire runs across some high voltage, to make sure that we're not losing any data, we run that cable using STP. So I have the majority of the patch panels laid out with UTP, keystone jacks. And then we have some STP keystone jacks as well, and they plug in the same way as the UTP ones do. If I was going to buy a patch panel that was made for STP, then of course they're going to be more expensive. But then I'm kind of wasting them unless I'm using all the ports for STP. Anyway, so we have two different kinds. This one is pre-populated, has all the ports already built into it. I'm going to show you guys how to punch these down today. So say for example, this one's in an MDF, this one's in an IDF. Typically your MDFs are going to have a lot higher port count. So this would be something that would be like in an MDF, IDF, in a closet somewhere, like say at a halfway point, to pick up a few offices or a couple of offices. And then your MDF would be 48 port or 96 port patch panel, and then everything would cable back to that MDF. I'm going to show you guys how to punch these down. So we're going to connect both of these, then we're going to test our connection. So I'm going to get this one out of the way. We're not using that one today. So as you guys can see, these are laid out. There's 24, 23, 22, 21, 20, 19, 18, 17, all the way through down to 1, right? We have our brown and blue on top up here, and then down at the bottom we have our orange and green. B standard is on the outside, and then down here on the bottom, B standard is on the outside. So our insides are A standard, outsides B standard. So we always do everything in B. So what I'm going to do is I'm going to try to find these are ones we use for skills tests. They're quite beat up. I'll try to find some that aren't beat up. 16 on this side looks pretty good. So we're going to be using the B standard. So on this one, we're going to be starting off with, make sure I'm counting these right. Yep, we'll be starting off with green. If I'm punching down port 16, You see there at the split, that's another way you can tell where your ports separate. There at the split between the IDCs. So we start off with green, then white, green, white, orange, orange. Then at the top we have brown, blue, and white, blue. So I'm gonna get another length of cable here, strip this back. If you guys never watched the other videos, I always try to set my strippers so that they just barely cut through the outside of the wire. That way I don't have to worry about stripping them back and actually getting into the copper. So basically just scores the outside of it, that I can bend it back and forth. Of course, every cable is a different diameter, seems like. All the ones I've tried lately have been. So basically just scores the outside of the cable. Then I can just bend it back and forth and break it off. That way I don't have to worry about cutting through the insulation on these. So what type of cable is this? Well, if we're going from an IDF to an MDF or IDF to IDF, we need to make sure that we're using the right kind of cable. Well, if you look at the outside of the cable, it'll tell you what it is. This is a Elite 1000 Cat 6 Giga Systems. It's 550 megahertz. UTP, unshielded twisted pair. This is 4 pair. This is 23 gauge. Shows that it can go up to 75 degrees C. And this is CMR. So this is copper multi-purpose riser cable. So, and we have, I'm trying to look at our footing markage on here. We have approximately 918 feet left in the box. So if we wanted to do some long runs, we could use this one box. So another thing, if you're punching down the entire patch panel and you have runs you're going to be putting all the way across, it's better to start off with the very ends and then come in over the top of them. So if I'm going to be punching this down, I'm going to do everything on this half coming in from this side. I'm going to do everything on this half coming in from this side. Some people don't feel that way. I do, because it makes sense. If we have to change a run out, something happens, we have to deal with MAC quite a bit. Doing low voltage cabling, MAC is moves, adds, and changes. So if I'm going to be punching down 24 through 13 on this side, I'm going to start off with 24, and then that way I can lay 23 over the top of it, 22 over the top of that, 21 over the top of that, so on and so forth, until I get all the way down to 13. Now, once you get these punched down, you can bend them up and then work on the ones behind them, but I don't want to have to bend up an entire row of cables to get to one side. So it's better to come in on one side with one and the other side with the other. That's just my way of doing it. Another thing is if you're having to do this up in a rack, they bolt into the rack like this. It's one of the tricks I've learned over the years. You have 2 rack bolts go here, 2 rack bolts go there. If I'm doing this inside the rack, and there's already cables attached to it, or there's not already cables attached to it, what I'll do is I'll just bolt it in backwards. I'll just bolt it in like this. That way I have a nice, good surface to push down on and do all my punch downs with. Makes it a lot easier for me. I don't have to worry about sitting it on top of a ladder and it's sliding around all over the place. I can just bolt it in place, feed my cable through, and then punch everything down the way I need to. So on this one, I'm going to do port 16, and then I'll depending on which one looks good on the other one, I'm going to do that one as well. So remember to keep your twists as far up as you can. And you can tell on this one isn't a enhanced or Cat 6A, so there is no center divider to keep your pairs separated, but still Cat 6. So I'm gonna get our wires laid out in the correct order. This one's brown first and then green first. So whenever you're laying them out, it looks like this. So then with this type of wire, you can spread it out just enough to get it open on the IDC, push it down. If you guys see this, I'm getting trying to get the twist all the way up to the very top. And I'll just leave those connected there, and that makes it a little bit easier for me. I'll separate this one. Spread that one out. And the same thing down here on the orange and orange white. I'm really just doing this to save time. Instead of stripping this and untwisting it all the way down, I can just separate the pairs. Then we can go back and punch them down. So I always want to make sure that I'm doing this correctly. And look, I'm not. See how the orange, white was swapped. So if you do a lot of these, if you're doing a lot of the same brand, then you get kind of into a groove. But you've always got to look, because not every manufacturer makes them the same. Push that one down. Then I can just flip the blade over, do the opposite side. It's the same one I was using the other day. It's kind of seen better days. It cuts through the cable, but for some reason it doesn't cut through the, well, it's dull. It's been used for quite a few years. It doesn't cut through the other side of the insulation. So if you guys can see this, the twist is as far up as I can get it on all of these. That cuts down on crosstalk, next infects, near in crosstalk and far in crosstalk, which helps with your data throughput. Make sure you don't lose as much data. So these can all be bent up and pulled out of the way. If you have to work on one behind it, you can do that pretty easily. Like I say, if I'm coming in this direction and I'm going to be populating the entire panel, then I'll start down here and move my way down. That way, if I have to work on, say, port 18, the only ones I have to pull out of the way are 17 and 16. I can get to 18 just fine. But if I was coming in all from one direction and I had to work on 18, I would have to pull a bunch of wires out of the way at once to be able to get to it. So just try to feed everything as nice and neat as you can. Think about the next guy that's coming in behind you, because it may be you. Try to do everything as nice and neat as you possibly can every time. Makes it a lot better on us. So you see I'm just barely cutting through the outside, and it breaks as it opens up. That way I can be sure I didn't cut through the insulation on the wire on the conductors. So we're going to do this one the same way. So we'll just flip this around. So think about this going from, you know, one closet 200 feet away to another closet 200 feet away. So this one I'm going to do on 8. 8 looks pretty good, you know, as far as the IDC goes. So on this one we have, let me see, our browns and our blue. Brown first. This one green, then orange. So we're doing solid stripe, and then solid stripe, or stripe, solid. So that kind of threw me off on the last one. And to note, one thing to note, guys, is try to keep these in the middle as much as you can get them. That way there's as much on one side as there is on the other. You don't want to have them all going to one side of the patch panel. And I thought I would be saving time, but I really just need to try and make everything nice and neat. So I'm going to go ahead and punch this down. Now, some of the problems we run into with these is they've been punched down so many times that the IDC gets separated, and it doesn't doesn't cut through the way it should. So I'm just going to split these open like I typically do with keystones. All right, so now we have this one done. So we have brown, blue, white, blue, green, white, orange, orange. So this one's punched down and this one's punched down. So what we need to do now is test our run. Typically I test with factory cable. Not that I don't trust my punch down ability for making RJ45s or APAC connectors. I typically just do this out of habit. I keep a couple of these in my box, and those are the ones I'll test with. So if you imagine this being 200 feet long, going from one closet to another, kind of give you an idea of what we do whenever we're doing low voltage cabling. Of course, this is usually sitting on top of a ladder. We can go through and plug this in. I'll show you guys what this looks like. And you see I'm testing at the same time I'm testing my patch cables and I'm testing my horizontal run. So this is 1 to 2, or 1 to 1, 2 to 2, 3 to 3, 6 to 6, 4 to 4, 5 to 5, and 7 to 7, and 8 to 8. And this is number 1. So what if you had a whole bunch of connections? Say you had an office that had 4 ports in it, and all 4 of those ports were punching down inside the patch panel. Well, to make sure that you're getting the right one, I'll show you guys these. We have little remotes that you can plug in, and they will tell you which one's which. So this one has a 5 on it, this one has a 7, and this one has a 3. So for example, I unplug this, unplug the end of my tester there and my patch cable, and I plug in a remote. It'll go through and do the same thing. It goes through and it checks the cable, make sure the cable is punched down correctly on both of my ends. But then it shows me a number 3. If you guys can see that, it shows me a number 3 on the screen. So that tells me that is remote number 3. Now we do cameras, time clocks, you name it, a lot here lately. So it's really good to be able to tell which one of these is which. So if I have say 3 offices, 4 offices, and we're punching down cables in all of them, I can go through and I can put a remote ID in each one of those offices, or 2 of them, depending on how many data ports we have, and I can tell you which one is in which office based on how it's punched down in the patch panel. So that one tells me that remote number 3 is good. So if you're testing a bunch of them at once, if I had a bunch more cables here, I could show you. We could go through and put all the remotes in. We have 8 total in the package, and we could go through and test 8 different cables at one time. So with these, you can actually test the continuity, and you can check to see which one is which, because it gives you a remote ID number. That is really handy if you're doing a bunch of runs at one time. So this is how you punch down a 110 style patch panel. Now, for those of you with really sharp eyes, you may have noticed that this is a Cat 5, a Cat 5e patch panel, and I use Cat 6 cable. In class, we use typically Cat 5es up in the ceiling, and we have a huge roll of it up there that goes from one side of the room to the other. So whenever these guys are going through and doing their test, to go through and do the punch downs, they're just cutting off what was used before and punching down the new cable. So it's all 5e. So I did this with a 23 gauge. Typically 5e's 24 gauge, a little bit smaller, but it works just fine. If you have any questions, comments, leave them below. Thank you.